So first off, let's understand a little bit about what is Ethereum. So the first question now, in the next 2-3 slides, we're trying to answer this, right? So the idea of Ethereum kind of was born post Bitcoin, of course, and it's an open source public blockchain platform. So it is very important to understand that open source and public are key factors that play into the popularity of Ethereum. The idea of blockchain is to bring in decentralization, right? That is more power to the people. And that is why open source and public nature of the blockchain is what made it one of the or has made it one of the most popular, one of the most lucrative blockchains to work on. Now, the other second part why Ethereum gained so much popularity is because this was one of the first blockchains that was successfully able to implement the functionality of smart contracts. What are smart contracts? We will look at it in depth in a bit. But these are the two main factors that Ethereum being open source and public, that is anybody and everybody across the globe is able to utilize this blockchain. The second is that anybody and everybody across the globe is able to build applications on top of this blockchain using this concept of smart contracts. There are some questions that are coming up in the chat. Some of them are really good ones. I'm going to take a pause somewhere, maybe after 20 minutes or so, to answer the question. Now, one of the other things that is popularly comes along with a blockchain network is a native token or cryptocurrency using which you can pay for the transactions on that particular blockchain. So Ether is the native token that is used for transactions on the Ethereum blockchain. Ether can be transferred between accounts and is also currently being used to incentivize something called miners. I'm not going to go into the concept of what is mining, what are miners. We already have some resources that we have shared as a part of the bootcamp, which you can go through. And there are also a lot of publicly available resources to understand the process of mining. Just a one-liner about mining with respect to Ethereum is that whenever new blocks are produced on the Ethereum blockchain, it is with the help of miners. Ethereum provides a decentralized virtual machine called EVM, Ethereum Virtual Machine, which is actually the pillar of this entire blockchain network. And this is the one that is used to execute the scripts called smart contracts. Now, since this is open source and public, all of the scripts are executed using an international network of public nodes that form the Ethereum blockchain. Give me 1 second. I'm going to switch off my Discord because it keeps popping and it's a bit annoying for me. Yeah. Okay. So when anybody asks you to define, like, give me an introduction to Ethereum, these are a couple of things that you can keep in mind while describing it to them. Today, let's take a look at how Ethereum kind of evolved and what was the mind space when Vitalik kind of put this together, right? So in 2013, Vitalik Buterin, who is the founder of Ethereum, right, published a paper before the project's launch in 2015, right? So Vitalik worked a lot on the Bitcoin ecosystem and wanted to use this entire network of nodes, right, which is Bitcoin, to be able to more than just transfer cryptocurrency, right? That was the mind space with which he published this paper, wrote the theory behind how EVM, a virtual machine, will be able to process information on this using this network of nodes. 2015 was when actually the first ever implementation, the bare bone implementation of the Ethereum blockchain was live. This was called the Frontier, right? It was specifically intended only for technical users, for developers to experiment how the blockchain network will work. In 2017, and this is a concept that you have to understand a little bit. Sorry, we have gone much further. There was a fork. So the forking again is a concept that is quite popular in the ecosystem. It was quite popular a while back. Now, not so many forks are happening. But the idea of forking is, as the name suggests, you have an entire blockchain, and the blockchain, when there are some critical changes happening in the blockchain, you may want to fork it into another version, right? So like the shape of the fork. Yeah. So you want to take the blockchain and fork it and make another version of the chain. So forking is not necessarily advised, but sometimes important if you are going to have a drastic change. So you want to leave the older chain and kind of fork into another chain, right? If you come from a programming background, you know that you can take an existing GitHub repository, fork out of that, and build on top of that, right? So that's the concept of forking. It's slightly more critical in blockchain and is more impactful. So you can read more about it. I will share some resources on our Discord. So the first Byzantium fork happened in 2017, where block rewards. So what are block rewards, and why I put this as a significant kind of event, right? Is because every time a miner creates a new block, they will get some reward, right? That's the incentive for them to keep creating new blocks. Now, block rewards were reduced from 5 ETH to 3 ETH, right? During the Byzantium fork. And this also, there were also some critical changes that were made in the smart contract functionality. So this Byzantium fork is one of the popular forks. That's why I chose to highlight this in 2017 when this happened. And in 2020 is when Ethereum announced the movement. It has been announcing for a while, but the actual movement started happening to proof of stake, which is Ethereum 2.0, also popularly known as the merge. There is a lot of speculation as to when this will happen. Everybody's waiting for this to happen, hopefully by this year, right? So 2020 is when the first action to move towards Ethereum 2.0 was announced. That is, the beacon chain, the genesis of the beacon chain happened. So in a blockchain, whenever the first ever block that is produced, it's called a genesis block, right? It's a Greek myth for a Greek terminology for getting started, I believe. And the beacon chain started producing block on the 1st of December 2020. This is the first ever step towards ETH2 and was considered one of the popular milestones in the whole Ethereum ecosystem. Block rewards were reduced from 3 ETH to 5 ETH to 3 ETH. So ETH, you see ETH, capital ETH is the symbol for Ether, and 5 ETH used to be rewarded earlier if you were able to, successfully produce a block as a miner. And this was reduced to 3 ETH. I missed the E in that. And now it is much lesser. I don't know the exact number now, but even now miners get rewarded for producing blocks because Ethereum is built on a system called proof of work as of now. It is slowly going to transition to proof of stake. The transition is in process. So a bit of why I think most parts about the why are kind of clear, because Ethereum was one of the earliest players in the whole blockchain ecosystem that showed that you could actually deploy code, you could process code using this entire decentralized network of nodes, right? That is why it is one of the most popular ones. The second reason why it is popular is that Ethereum virtual machine, or EVM, the way EVM works, there are a lot of other layer 1 blockchains that are picking up the popularity of EVM, that is this virtual machine, and building their own network logic on top of that. This is why I chose Ethereum / EVM as one of the networks, one of the underlying infrastructures for us to understand, because EVM has gained so much popularity. It is one of the most stable virtual machines, about which we have most of the information ready with us. And so it is easier for us to understand how it works under the hood. So a little bit now we are moving towards the what. Like, what is Ethereum? What does it have? And how do we kind of look at it, right? So there are a couple of features of Ethereum which which make it execute the way it does. The first are Ethereum accounts. So accounts on Ethereum are a way to interact with the network, right? So accounts, or you can create, anyone and everyone can create an account on the Ethereum blockchain network because it's a public network. Using those accounts, you can interact with the network, or you can even interact amongst each other, right? Two accounts. So think of accounts as your entry to that particular blockchain, right? And accounts are represented by hexadecimal addresses. And you have been asked to share your Ethereum address. If you're a part of the Solidity Bootcamp, you have been asked to share your Ethereum address, which is your public account address, right? Ethereum virtual machine, EVM. This is the underlying machine which is going to help us execute smart contracts. So everything you're going to study week 2 onwards for the Solidity Bootcamp is going to have some contextual requirement of how EVM works, because Solidity, the programming language that you are going to study in the bootcamp, is going to extensively depend on how EVM works. Smart contracts, one of the important features. What are smart contracts and how do they work? We will take a look at that. And we will also take a look at what are transactions and what is associated gas, right? Now let's take a look at the first feature, that is accounts. Let me pause a bit and see if there are any significant blocking questions. Okay, 3 ETH and 5 ETH are clear. Yes, okay. Ethereum is a type of a blockchain network. Yes, that's right. There is nothing called ETC20, it is ERC20. It is a type of standard for tokens, which we will talk about later. So, okay. If there are any other questions related to the why, please put it on the chat. So I want you to be very clear about why you are studying this particular type of blockchain network as a base concept, right? Now, accounts in Ethereum, like I mentioned, are your gateway into the blockchain network, right? So you create accounts and that gives you the ability to interact with the network and also ability to interact with your peers on the network, right? So here are, for example, okay. So there are two types of accounts that are there on the Ethereum blockchain network. The first one is called an externally owned account. You may popularly see this as being written as EOA, right? Let me just EOA. Okay. So, Divya asks why we are using Ethereum. I didn't understand. So Divya, when we spoke about like why we are talking about Ethereum, because Ethereum is one of the earliest blockchains that implemented the concept of deploying programs, deploying code, and being able to compute that code using a network of nodes, right? That's why it is one of the most popular ones. And EVM, the Ethereum virtual machine, is so robust and it is written so very well that even other layer 1 blockchains try to take EVM and build on top of that. That's why I have chosen Ethereum and EVM as a starting point. Using this knowledge and information, you can learn any blockchain quite easily, right? So, okay. So coming back to accounts, there are two types of accounts. One is externally owned accounts, EOAs, and another are contract accounts, right? Now, externally owned accounts, as the name suggests, are owned by a user, right? And they are controlled by something called a public-private key pair, right? Whenever you would have created your MetaMask account, if you have not created a MetaMask account yet, right? Then you should. If you have already created a MetaMask account, you will see that there is an address, an account address that gets generated for you. Okay, that's your public address. Now, this public address is associated with a bunch of words called mnemonic that the MetaMask would have asked you to save, right? Now, this mnemonic is nothing but your secret phrase, right? Like your password. So a combination of these two create an externally owned account. So a beautiful analogy to this is a bank account, right? In a bank account, you have your you have an account address that you can share with others to transfer money to you. However, there is also a password associated with your banking account, which is only known to you and is used to control the privacy settings of your account, right? So that's your public private key pair. In cryptography, every account, in cryptography, you can generate something unique with the help of a public private key pair, right? So that exact concept is used over here. So externally owned accounts are accounts which are owned by the user. You can send ethers, you can send a particular supported cryptocurrency to that particular externally owned account, right? Now there are, and externally owned accounts can talk to each other, etc. We will come to that in the transactions part. Now the second type of account that we use are called contract accounts, right? Whenever you create some kind of smart contract, which is a piece of logic, right? And you say that you're storing the smart contract on the blockchain. What does that mean, right? Because blockchain is just a network of nodes. So where are you actually storing this? So this is where whenever you deploy a new contract, something called a contract account gets created for you for that particular contract, right? And these contract accounts are the ones that are stored together with your externally owned account, right? These contract accounts are actually controlled by the code, which is the smart contract code that you have written. So contract accounts are not the same as externally owned accounts. You can just go and create an externally owned account because it's a public blockchain. Anybody can create a MetaMask account for themselves, right? An externally owned account. However, a contract account can be created only when a particular contract is being deployed on the blockchain, right? So automatically a contract account gets created. Now, to show you a little bit about how these transactions or how the accounts interact with each other. Sorry, my apologies, this picture is a little blurry, but I think it's clear as to what's happening. So this is where the transactions come into picture, right? Every time accounts interact with each other, right? Whether it's two externally owned accounts interacting with each other or an externally owned account interacting with the contract account, in turn interacting with the contract, everything is in the form of transactions in the Ethereum blockchain. Okay? Now, how can accounts interact with each other? Let's take a look at the second one. Let me see. So, oops. Sorry. Okay. Yeah. So two externally owned accounts can interact with each other, right? So that is simple as one person sending some money to another person, having some transaction, right? So one externally owned account, that is person A having an account, can send some ethers to person B who has an account. These two are externally owned accounts. They can interact with each other. Now, when you are sending when account A is sending some money to account B and vice versa, these are in the form of transactions, right? These are called value transfers. You're transferring some amount of value from one account to another account, right? Now, within this itself, you can see, and now let's go to the above image, right? The above chart or whatever. There are two types of transactions. There are two more types of transactions that can happen. One is that an externally owned account can call a contract account, right? This can be either while you're creating a contract account. So as a user, you're deploying a contract on the blockchain. So like I said, automatically a contract account gets created. Now, when there is a contract account, as a user, you can interact with a smart contract. For example, when you're interacting with some DeFi apps, right? I want to show you some DeFi app, maybe Uni Swap or something. So when you're interacting with the DeFi apps, right? Decentralized finance-based apps. One of the popular ones is Uni Swap. It's a decentralized exchange. what you do is you connect your wallet and then you can swap some money here. You can swap one cryptocurrency to another. That's it, what it does, right? In simple terms. Then what you're doing is actually this application will have its own contract. When you connect your wallet, you are connecting to an externally owned account, right? That's owned by you. For example, my MetaMask account right now, it's owned by me, right? So this is an externally owned account. Now, what happens when you connect to an externally owned account here? You are now into the system by you are representing yourself as the externally owned account. And once you connect the wallet and you do some swap, you do some action, you're interacting with a smart contract, right? So you're initiating a transaction between an externally owned account and a contract account. Now, there might be another type of transaction, that is contract accounts initiating transaction to another contract account. So this is one of the interesting things about EVM, right? The way EVM is structured, that contract accounts can actually talk to other contract accounts. That is, these are called cross contract calls. One contract can talk to another. So it's not just me as this external account holder who can talk to a contract, but an existing deployed contract can also talk to another contract. So this is the other type of transaction. When you see generally on explorers, so here is a good time to introduce the concept of explorers. So how do you see these transactions? What is a particular account doing? How do you see that, right? So let me show you a live example. I'm going to copy my account address, right? So I'm going to paste it here and I'm going to search. So this is a block explorer, as the name suggests. It takes data from the blockchain and shows it to me, right? So for this particular account, you can see that I have a balance of $145.95. It's not much, but yeah. And you can see what are the different transactions that I have done. So here is where we are kind of condensing all the concepts together, that it's a public blockchain. So you can see that all the transactions are public. You can see what are the transactions made by my externally owned account, right? So I have done some transfer. You can see USD and all that. When I bought the ENS name, the phoenixguild.eth, right? So that transaction is shown here. Commit, transfer, all these things are shown here, right? It's public to everyone. Now you see one more tab here called internal transactions, right? So you see why there is an internal transaction is when I bought the ENS name, that particular contract has interacted with some other contract internally, right? So there has been an internal transaction. One contract has spoken to some other contract to eventually give me this ENS called the phoenixguild.eth. So these are the three types of transactions that can happen on an Ethereum blockchain with the underlying EVM. And the number of accounts that you can have on an Ethereum blockchain are two. One is an externally owned account and one is a contract account. I see the chat bursting with questions, so let me take a break and see that. Okay. Yes, Ethereum request for comment. That's what ERC means. So there are two things: EIPs, Ethereum Improvement Proposal, Ethereum request for comment. These are both used in a way to improve the Ethereum ecosystem, create standards, etc. So there is a good question: is the private key the password or the 12-word phrase? So the private key is neither your MetaMask password nor the 12-word phrase. If you go to MetaMask and you go to the settings, right? You can see three dots. When you click on account details, you can export private key. I will not export mine because otherwise you can see my data. You can click on export private key and you will see something similar to this. Not hexadecimal, I think I forgot the number of bits, but that is your private key. The 12-word phrase that you see, which is called the mnemonic, is used to generate the private key. So your public private key pair is what matters, but there is a mathematical equation behind this called randomness, etc. So you first generate set of mnemonics and then you generate a private key out of that. I have a really fun exercise that I'll probably add to the content, which will help you understand how this public private key pair generation happens. So yes, it can be 12 or 24 based on something called the BIP that you're using. Again, this was Bitcoin improvement proposal. So this one, MetaMask uses something called BIP69, from what I remember, or BIP79. But there is an algorithm to generate the private key. The underlying algorithm that is used is called ECDSA, Elliptic Curve Digital Signature Algorithm. Slightly complex, so I'm not going too deep into that. It's got to do like with curves and stuff, the elliptic curves, obviously, as an instance. So can you show an example of contract account? Sure. So what are contract accounts? Whenever you create a new contract, an account gets created, right? So let me show you maybe like, I don't know, have you heard of this popular NFT called CryptoPunks? It's by Larva Labs. I'm just trying to find their contract address. That's why I'm here. It should have. This punk is okay. Where is the contract address about? Let's just Google crypto punks contract address. Okay, amazing. This was straightforward. Understand. I chose the wrong contract address. So you see, this is a popular NFT contract. It's a contract actually, CryptoPunks, right? It's a smart contract. You can see that this is a contract. You can see the contract code. There is some piece of code that is deployed on the blockchain. What is the piece of code? This is the piece of code. When this piece of code was first ever time deployed on the blockchain, that's when an account was created to store this piece of code. This account is known as the contract account, right? And the contract account is similar, the address of the contract account, like you see here, right? Contract, and this is the address. It looks the same as your Ethereum account address because this is an account. So this is a contract account. Every time a new contract is deployed on chain, you can create something called you get something called a contract account gets created for you. Now you can interact with this contract account, right? For example, if you see this transaction is a bidding transaction for this punk, right? Somebody has bid, they want to buy a crypto punk from a particular address to this contract account. That means the buying is happening through the contract, right? So this is interacting between an externally owned address to a contract address. If you see, there are internal transactions as well, where some other internal contract has called in turn. So CryptoPunks is the from here, and it has called some other address to send this 120 ether or something. It's probably a sale that happened, right? So CryptoPunks contract address account has called this particular address and given them 120 ether. It's most likely a sale that happened. So this is an externally owned account. This ugly punky.eth, local degen.eth are all externally owned account, punks OTC, right? And this is a contract account. So here you can see externally owned account interacting to, making a call to the contract. Here contract itself making a call to an externally owned account, right? So this is these are the different types of transactions that can happen. All right. Rug pulls in NFTs, right? Rug pulls are a different concept. You can do a lot of things with the transactions, the way transactions work with in the ecosystem. But I will share some examples of rug pulls using code. Maybe So it's not got anything to do with the accounts, right? Drug pulls can be done using contracts themselves. It can be done using externally owned accounts, etc. So ENS, a lot of questions about ENS. I will post an article. What is ENS? ENS is Ethereum name system. It's a slightly more advanced concept. So I will post a link, and if you are more interested, just go for it. Yes, is there, once again, I'm just let me read the question a bit. What is the use of internal accounts for a layman user? So internal accounts, like I said, right? There's nothing called internal accounts. There are internal transactions. That means when one contract is talking to another contract, there are internal transactions happening between the accounts, right? So for a layman user, or for any user, right, you may not, if you're building a huge product, you won't be just writing one contract. You might be writing multiple contracts, and you might want your contracts to talk to each other at some point in time, right? And that's when your internal transactions happen. Does the private key keep changing in a public private key pair? No. So the moment your private key has changed, your public key changes, and the whole account concept changes, right? Ethereum name service is similar to DNS. Yes, that's right. It's slightly different, but the idea is similar. Uh, any contract that I deployed from testnet that can be shown. Yes, I can show it, but I think it will make more sense to do it when we are doing the solidity part of things, right? You can, I just showed an example of the CryptoBucks contract, right? This is deployed on mainnet itself by testnet. You can see the contract. This is a piece of code. This is exactly the contract that's deployed. The exactly piece of code that's existing right now on the blockchain. Right? So you can see this piece of contract. Why I don't want to get into the nitty-gritties of the contract is that it can be little, without understanding the basics of solidity, it can be a little difficult to understand. So maybe once we get there. Do you mean, is there a way to differentiate between contract account and externally owned account? This is a great question. To be honest, I never thought about it. However, I think on the Explorer, it just shows up that this is a contract, and you should be able to see from the transaction history that when you see the contract account, there is the creation associated that will come from an externally owned account. That is EOA. That's somebody has asked that as well. Do you mean is vice versa minus 120 Ether? I'm not very clear about this question, what that means. I don't have the context of this. Can you show an example of a contract account interacting with a contract account? Yeah, I don't have an example transaction, but I can show you what are cross contract calls if that's of interest. Popularly used a lot in Uni Swap has factory contracts, so not near. Let me say Uni Swap. Let me see. Okay, Uni Swap factory contract.
No, sorry, one hour. So you have a key, so I don't.
Sorry. Okay. So I don't know. I'm gonna get so contract. Oh, wait. I know where to find it. Proxy. Yeah, you can see calling other contract. So you can see here, this is one contract called callee. This is another contract called caller, right? So caller here is calling this contract called callee. So whenever this transaction gets executed, what will happen is basically this will make a cross contract call to this particular other contract, and this will show up as internal transactions. So this is one contract interacting with another. So you have to deploy both the contracts separately. You will deploy the callee contract, a contract account will get created. You will deploy the caller contract, a contract account will be created. And once you call this function, set X from address for the caller contract, it will call internally the callee contract to do something. And that's when you will see an internal transaction happening. Is that good to go, Pratiksha? Is a contract account interacting with EOA an internal transaction or only contract to contract? So generally it is contract to contract interaction, but sometimes the explorer, so by definition, it is supposed to be this way, right? That it is contract to contract is supposed to be internal. But sometimes the explorer may show the other way around. However, so the explorer, right, how it shows is whenever a transaction originates from a contract account, it shows that as internal transaction on the explorer. But yeah, I mean, it could be in a way, because you trigger something from an externally owned account to the contract, then contract triggers something to another externally owned account. So yeah, I'm not really sure how to define it, but yeah, you got the point, right? So 120 Ether question. There was a from and to and had a value of 120 and some sale happened, which means contract, no. So this one that you saw, the sale happened. Contract did not get 120 ETH from the buyer. Contract sent to 120 ETH to the buyer, because you saw that the from was from the contract. It was not from the buyer. So you see the 120 from is from the contract. So contract sent 120 ETH to the buyer. It's not the other way around. So if there is a value going from contract to EOA, it is still 120 only. See, it's only the direction in which the value flows. There is no negative minus connotation here. So when an externally owned account, so it's just the direction shift. When an externally owned account is buying, it will send 120. When you are selling, you are giving it back, right? So that's what is happening. Okay. If we deploy this code, will both contracts be deployed to the multi-calling contract? I'm assuming that's the question. So yeah, this is not a buying. That's right. This is selling. Sorry. Let me finish this 120 Ether one. If we deploy this code, will both contracts be deployed? No. You have to deploy each contract individually. So I don't want to go to remix, but let me go so this is clear, and I don't want to leave anything hanging. So this is an ID you will be using throughout your bootcamp. So just better to be familiar, but it's not required to learn this week. So when you paste the code like this, it's throwing me an error because my compiler version is lesser. It asks for 12 and 10 and above. So I'm going to set that. And when I deploy, right, when I want to deploy this piece of code, I can choose the contract I want to deploy first. So I can first deploy the callee, then deploy the caller, vice versa. But I have to deploy both of them individually, because each of them will have their own contract accounts created, right? And then one will talk to the other, etc. So that's how we have gone too much into the code now. Let's come back 2 steps back. Awesome. So one of the most important things about the Ethereum ecosystem is the Ethereum virtual machine, the EVM. It is becoming so popular and so strong that many layer ones that are coming up on top are building on top of the Ethereum virtual machine, right? Ethereum virtual machine, you might have heard of other different chains. There's Harmony protocol. There is Avalanche, which says that they're EVM compatible. That means the smart contracts on that particular blockchain can be processed on the Ethereum virtual machine. So this is the main idea of Ethereum virtual machine. It is used to process the scripts that are smart contracts, right? There are some more questions coming. I'm going to take them up. So because I have little more to finish, I will take them up in maybe another 5-10 minutes. So Ethereum, when we talk about Bitcoin, right, we always say that Bitcoin is a distributed ledger, right? Wherein information in the form of transactions is being stored across the ledger, right? And the ledger is distributed across a bunch of nodes, which are a part of the network. Now, Ethereum brought about this idea of computation on using these nodes, using these networks. So it's no more just a ledger. It's a distributed state machine, right? State machine is a popular concept in computer science and programming. So when we want to talk about state machine, right? Here are some examples or some principles associated with finite state machines. It's not necessary for you to know this, but just to give you an understanding, right? Whenever we write some piece of code, we have some variables, right? That is, why do we create these variables? Because we want to store some value. For example, if we want to say that X amount of fish was transported from point A to point B, right? Or yeah, let's keep that as a basic example. We are going to input the value that the amount of fish is like 1 kg, 1 kilogram or something, 1 ton, 1 ounce, right? And this is going to be a variable, right, on our machine, on our code. And the place where this particular fish has started, or the box of fish exists, is point A, right? Now, when this fish moves to point B, we want to change the state because we check the amount of fish and it's not the same. It's probably couple of them have been reduced, right? Couple of them have been removed from the journey, right? So there will be a change in the state of this variable, right? So the value of this variable will change. Initially it is 100, then maybe it becomes 20 or 80 or something. 20 is way less, let's say 80, right? So from 100 it turns to 80. Now this change is happening on that particular variable, right? And we also change the place, right? There are two variables, the amount and the place. Now the place is initially point A, then it becomes point B, right? So these are a set of states or transitions that are happening to this particular variable, right? Now a state machine depicts exactly this, right? It always, the state machine at one point in time can only be in one state, right? At any point in time, the amount of fish and the place will be just one value. It can't be multiple values, right? It can't be in multiple places at the same time, right? So this is where your finite state machines come into picture, which depicts the change of the states of that particular machine, right? So finite state machine will have a set of states and transitions, right? It will have at least one state at any point in time. It cannot have an infinite number of states. It will have a starting state and it may then go on depending on how your machine works, right? So a simple example is a vending machine. Initially, the vending machine is just in a static state. The moment you press something, the vending machine becomes active. Then it asks you to press a button. Press a button of the whatever, the number that of the product that you want, right? So now it is an accepting state. It's waiting to accept some information. The moment you type in your button, B12, A12, whatever, oh, I see Snickers. Never mind. So moment you press the button, it now accepts the input, right? So it is in processing state. After it processes, it sends you the Snickers, right? So now it is completion state. So this is a state machine. Obviously, there is much more to a finite state machine than what I described from a computer science concept. But this is the primary kind of construct of EVM, that it's a distributed state machine. That means the state of the different changes that are happening, that is the smart contract changes, they will be distributed across the nodes, right? That's the power of the public blockchain. Now, what is the state in Ethereum, right? When we say state machine, that means we are saying some information about the state will be present across the nodes, right? So a state in Ethereum is, think of it as a large data structure which not only holds the accounts and the balances like Bitcoin, which holds only the accounts and the balances, right? Because it's only about transferring cryptocurrency from one account to another. However, there is now some programming is also happening on top of Bitcoin. There's an organization called Stacks, which is trying to use the concept and those stuff. All right, digressing. But so the entire data structure not only holds the accounts and the balances, but also a machine state. That is, what state is this Ethereum virtual machine in right now? That means whatever are the different contracts that are deployed, whatever are the different variables that are a part of those contracts on the EVM, all of the states of those are captured in the machine, right? All of those put together form the machine state. The state of this machine can change from one block to another based on the predefined rules of the EVM. How does the state of the machine change, right? And this machine can execute arbitrary code to change the state of the machine. This is very, very important. It may seem very complicated when you're actually reading this from a documentation perspective. It's very simple, right? Think of it as you are inputting some data. It's in some state. You apply some logic to it, right? This machine executes that logic and its state changes. This machine is able to record the state change. It's a state machine, right? That's how you see the changes that are being made in your contract. There are contract interactions. You interact with the variables, the value of the variable changes. Everything is recorded on the blockchain, right? And the EVM is your base. Your EVM is the core that is doing everything for you. So whatever piece of code that you write in Solidity, whatever state change happens going forward that you're going to learn in the bootcamp is all facilitated by the EVM. That's why it's very important to understand how this virtual machine functions. This complicated diagram is just to fill the slide. I'm not going to explain this. Requires a bit more understanding of what are stacks, what is memory, what are program counters, etc. Which you can go through the documentation and probably kind of, familiarize yourself. Some more quick pointers about EVM. It executes as a stack machine. So when you can see this guy piling up things on top of each other. So that's a stack. Stacks follow the principle of first in, last out. The first that goes is at the bottom, and whatever you put recently, you can pop out recently. So this EVM stack machine can have a depth of 1024 items. Each of them are 256-bit words that are stored on the stack. And during execution, the EVM itself maintains a transient memory. That means the data of the EVM does not persist between transactions. However, the data that is there on the contracts, so contracts themselves have their own memory and they persist the data within them, right? So there are blockchain specific operations that this virtual machine supports, such as addresses, balances, what is the block hash, etc. Right? And then specific to smart contracts, which are converted into something called bytecode so that the EVM can read the instructions easily. There are instructions of the smart contracts are processed in the form of opcodes, right? So these are operations like XOR. So slightly, maybe those who are from computer science background have a better understanding, but there are some opcodes which are called form the instruction set of this EVM, and all the instructions that EVM gets are in this format with the opcodes. Quickly going through what are smart contracts. Smart contracts, by now I'm sure all of you are already familiar, is a piece of code that is stored on the blockchain and it is programmed to execute some operations, right? The smart contracts have some conditional workflow, control flow, and these conditions are written within the smart contract according to which it executes. So what is it? It's nothing but a computer program that comprises of the logic for your applications. Once a smart contract is deployed, no one can change anything on it and it remains immutable. So this is one of the properties of inherently that provides both security and also sometimes is a pain because you cannot change the smart contract once deployed on the blockchain. So you saw the CryptoPunks contract that's deployed, right? You cannot change that piece of code because it's now forever going to be the same. That's why there is the idea of proxy contracts and factory contracts, using which you can control to an extent that you can change what it is pointing to. There are upgradable smart contracts that are coming up, which are becoming popular. You can upgrade the smart contracts, but there are some rules and constructs that you need to follow with respect to that. Smart contracts operate with a very limited execution context. What that means is not every smart contract knows everything about the entire blockchain, right? What they know is about their own state, the variables that are there in their own contract, the context of the transaction that called them, you created the contract or you spoke to the contract, all of those contexts it will have, and some information about the most recent block. It won't have the entire blockchain's information, right? Because the chain in itself is really huge. There are three types of transactions, as we have already seen: transferring cryptocurrency from one account to another, deploying a smart contract, which we saw, and then transferring ether from an externally owned account to a contract. So, and then contract interaction as well. That's probably the third one, internal transactions. Quickly, what is gas? There is an in-depth video about decoding gas for those who are a part of the bootcamp that explains it much better. But basically, what is the concept of gas and why it was introduced? Every time you do a transaction on the blockchain, right, you are actually, there is some computation happening, right, at the underlying, and you are paying, you need to pay for that computation. The network of nodes that is processing this transaction, you need to pay them. Why was this concept of gas introduced? Because if you pay them in the native currency, that is ether, the price of ether or the native currency keeps fluctuating. So you're not able to determine what is the best price at any point in time to pay for that transaction, right? So you can fix it as like a couple of dollars or so, but is dollar really the kind of best currency you want to peg to? Probably no, and not in the decentralized universe anyway. So that's where the concept of gas came into picture. That is, for every transaction, there is some amount of computation that needs to be done. Why don't we calculate the price of this computation in a unit called gas? Okay? So gas is nothing but a unit of computation. That's all. So it is the amount of ether that you need to pay in order for your transaction to go through. It could be a transfer transaction, that is value transfer. It could be creating a new smart contract. It could be calling an existing smart contract. It could be one smart contract having an internal transaction with another smart contract, in which case you need to supply sufficient gas amount to the first smart contract so you can call the second one. For everything that you are perform, every time you want to interact with the blockchain and perform some operations which require some computation at the underlying, you need to pay gas fees. So gas prices or GUI is chosen over ether, as I said, because it's a volatile currency, right? And the gas itself is more or less fixed based on the bytecode of the instructions. What does that mean? Like I said, every instruction that you're giving to the EVM, right? You are saying transfer X amount of money. That's an instruction, right? That instruction has a fixed amount of money that is required to execute that instruction. Fixed amount of units, not money. Fixed amount of units that are required to execute that instruction, right? So the amount of units to execute every instruction is fixed. What changes is that how much are you willing to pay per unit? That's your gas price, right? So you calculate your gas as the amount of money that you're willing to pay per unit into the number of units that is required for that particular instruction to go through. Wei is the smallest unit of ether, where I have completely written this wrong. 1 into 10 to the power 18 Wei represents 1 ether, right? I wanted to do this, but I think we are already like past time. So maybe I will share the slides with you and you can just take a look at what is Ethereum 2.0 all about. It's all about proof of stake. What is the problem that they're solving? What is sharding? Just basics of that. Nothing much. What is beacon chain and what it does. And yeah, I will share the slides because there are questions which I want to take. So at least the existing concepts are clear. Okay. Maybe we just do it like this. If we redeploy, the account address changes. Yes, that's where I stopped. Is the EVM is outside the ETH ecosystem or inside the? I don't understand. What do you mean outside or inside? It's a virtual machine, right? It's a concept on its own. It's called Ethereum virtual machine because it was built for Ethereum. But the virtual machine and the way it functions, see, uh, any machine, right? You think of a car engine or something. It's a machine and you call that car engine as some name, right? You give it a name. But if you know how the mechanics of that machine works, you can always replicate that machine. Actually, not engine, a car itself is a machine, right? So you can replicate the machine concepts anywhere. It's just a concept, right? It is called popularly as EVM because it was created for the Ethereum ecosystem. But it's used by other chains. It's used by a lot of other chains. If we deploy only the caller contract and not the callee, will it revert back or throw an error? Yes, it will. Because it's not able to find the other contract, right? It will throw an error. The caller will be, wait, if the question is clear, this is a question. If we deploy only the caller contract and not the callee, the cross contract, will it revert back or throw an error? The contract deployment will happen. But when you call that specific function, it will not go through, it will throw an error. There is a question you can record as well with Bitcoin. You can record the accounts and the transaction, yes. But Ethereum has an EVM associated with it, which is recording the state transitions. EVM is written in assembly. Yes, in assembly. That's right. Adding to state change, any changes are converted as a state, and even a small change to transaction. Sorry, I'm not getting the question. Any changes are converted as a state, and even a small change to transaction are converted as state and given out as AMC. Do you mean any changes that happen on the blockchain, are they recorded as a state change? See, that's the thing, right? Not every change is a state change because you need to, this is something like, how do I explain? You need to have the state variables, and those the changes associated with those variables are the only changes that will be recorded, right? However, whenever you make a change, whenever there's a change that's happening in the ecosystem, in a way it's a state change. So, but what reflects, what gets captured are the state changes that are particular to that particular ecosystem. Is that clear? I don't know how else to kind of put this. Yes, you can abuse intellectual property. You can make your own CryptoPunks copying all the available source code. You can do that. However, that's why the whole, so the public part of things, right? There are two ways to look at it. One is if you go public first, you have already published the contract and everything, right? There are a lot of people who have CryptoPunks duplicates, but everyone knows that the first ever CryptoPunk that was published has this contract address, and this is the specific code that they're looking at, right? So when you go to the Larva Labs website, it links to this particular contract. So you know which is the original one. However, it's so that it is required to keep things public in a blockchain, from my opinion, open source and public, so that people can learn to take from the existing piece of code and build on top of that, right? So that's how the being public helps you. Of course, there are cons to it. Anybody can take the code, anybody, you can deploy the same contract code right now and create a CryptoPunks of your own. There is no one stopping you from doing that. But the idea around CryptoPunks or any other NFT is more community, not really the technology from my perspective. So doesn't make much of a difference. And also that's why people, there is so much FOMO, right? People are building fast because they want to be the first in the game to create something new, to say that, hey, we deployed this contract, we created new logic, here it is, it's publicly available, you can go see this. That has some value, to be the first mover in the industry. All right, when we create the account at first, how do we get Ether to pay for gas? So whenever you create an account at first, for example, if you have created a MetaMask account for yourself, you have to buy Ether. Ether for Ethereum, you have to buy 1 tokens if you want to execute on Harmony. You have to, when you create an account on Solana blockchain, you need Sol to be able to pay for gas fees. The native currency is what you need for paying gas fees. You can pay gas fees in other currencies as well based on the logic of the app and all. We're not going to go into that, but you need to buy the cryptocurrency and then you need to pay for gas. Some great resources about gas fees. Thank you, Juliet. Juliet has shared some great resources about gas fees. I'm going to copy this and maybe post it on our Discord as well. I will make a note of it, maybe add in speaker notes. Yeah, so that some great resources are here. There is also a video that I've recorded for the Solidity Bootcamp, so you can go through that as well. How did Polygon decrease the gas fee? This is a larger question, but Polygon is not exactly Ethereum. It built something called side chains. So it not all the computation is actually happening on main chain. So why are we paying so much gas fee? Because there is computation that is being happened, that is happening by a huge network of nodes, right? They are doing the computation, so we are paying them for doing it. However, when you think of side chains, there is a different concept altogether that they have implemented. So this is called plasma chains. That's how it started, Polygon. And you don't have to pay so much for computation on the main chain. You can just do it in the side, and then the dispute resolution will happen in the main chain. That's how they decrease the gas fee. There are a lot of other chains, layer 1 chains that are coming up that have very reduced gas fees. You have Harmony, you have Near Protocol, you have Solana. These are all trying to tackle this whole gas fees issue, right? By coming up with a different type of infrastructure. Near Protocol uses something called Sharding. Solana uses something called proof of time. I forgot, history time. And then there is Harmony that also uses some mix of sharding and kind of a similar algorithm. But yeah, proof of stake is something that is likely to reduce, and the whole sharding part. Regarding sharding, before that, is there a correlation between real world currency and Ether? Yeah, I mean, correlation as in terms of the price, right? You can see that 1 Ether is like 3,000 something XBC dollar and all that. But real world currency is fiat currency and Ether is a cryptocurrency. So the only relation that is kind of correlation that I can see is like in terms of the price, right? Like how much fiat do you pay for buying a cryptocurrency kind of thing. The whole currency tokens and the whole like evolution of money is a very interesting topic and something I tend to go into a rabbit hole sometimes, but I'm happy to share resources if you're really interested. Sharding is, so in simple terms, if you see this, like sharding is basically when an entire blockchain is split into smaller shards, and each of these shards act as their own mini blockchains, doing stuff that the bigger blockchain would do. And then there is something called a beacon chain, that is like the master. Yeah, I don't like to call it the master, but basically it is keeping track of what all the different shards are doing. This is the simplest way to explain sharding. I know it's a slightly more complex topic. I have some resources that I created long back for near protocol on sharding, and I'm happy to share those videos. They're on YouTube as well, very public. So how does blockchain app adds the gas fee in their transaction fee? So the transaction fee itself is the gas fee, and then on top of that they will add some x percentage as their profit or whatever, their transaction fee that they want to charge. So they don't have to add the moment you make a smart contract call, the gas fee is automatically included in that. Plus, if you're charging some extra fee, it will come in as payable. TPG focus on all kinds of blockchains. Yes, we are blockchain agnostic. We are a community, the Phoenix Guild. So we don't really focusing on a particular blockchain. For the Solidity Bootcamp, obviously it makes sense for me to pick EVM because it is the bigger machine and it is kind of, gives you context as to why you're learning what you're doing. And if this is your first entry point into blockchain, uh, for both devs and non-devs, it is very useful to understand the whole Ethereum ecosystem. So that's why it's my choice to pick. But we are going to have a lot more boot camps which are going to be on near protocol. We are already doing a study session for Rust, which is associated with Solana. So we are, of course, how is the number of units decided for instruction sets and who decides it? It's already decided at the compiler level. I can show you gas units for opcodes. You can find an opcode sheet. So you can find it over here. So you can see here, right? That stop is 0 gas. Add is 3 gas. Multiply is 5 gas. Subtract is 3 gas. It's already decided at the virtual machine level. So I'm happy to share this resource here for those interested. Also will put down in my notes, so I will share this later. The community. Awesome. All right. I think we are like super like way above time. I really apologize for that. But thank you so much, everyone, for bearing with me a little bit more extra time. But I really appreciate that all of you are keen on learning.